We're going to go ahead and start talking about locating points and midpoints. We've talked about distance. We've talked about segment addition postulate. In the warm-up, we have a segment addition postulate problem. In what I was making sure that my students understood whenever we taught this was understanding this word between. Okay, that word between is going to be very, very important, and we'll see what happens. Why we need to know the difference between. We need to highlight that word between. When we have the length, find the length of segment DE, if D is between points C and E, we remember, I'm going to go through this quickly because this is a review. I do highly encourage that you pause, try this on your own, please, and then resume it to see if we got the correct answer. So here, D is going to be between C and E. So here, I've got my endpoints C and E. D is somewhere between. I would say, mark it where it's obviously not in the middle. Okay, obviously not in the middle here. And then we will be finding DE. So we're going to be finding this length right here. We're going to be seeing here that CD, the length of CD is 13.2. And the length of CE, the entire thing, is 27.8. So with our part plus part equals whole, this one we can label DE, we can label as X, what we're looking for. We have 13.2 plus the other part X equals the entire thing 27.8. So here we just need to work algebraically. Get rid of that 13.2, subtract from both sides. We're going to find out that X, our missing part here, is 14.6 centimeters. The next one, we are going to find the average, or also known as the mean, of 15 and 27. This will be very important. We're going to see this in today's lesson. The average, we add the two together, and we divide by the number of numbers there are, which is 2. So here, the average for this will be 15 plus 27, and we're going to divide it by 2. And we're going to get 21. Now we are going to move forward and we're going to start talking about the midpoint of a segment. Okay, the midpoint of a segment is a point that's going to be halfway between the two endpoints. Okay, so if we have M as the, it should say, I just now realized this should be an M, let's make that into an M, is the midpoint of segment AB, then AM is equal to MB. Okay, again, the AM without the segment bar above means the measurement, the actual number. Numbers are equal. And then we see that now when we put the segment bars over it, we need to put the little congruent mark over it, saying the actual physical segments drawn on the page are congruent. And that's where we have these congruent tick marks. Okay, we need to make sure if two things are congruent, we put markings for that. So let's take a look at this first one here. We've got find the midpoint of a segment on a number line. Find the mean or average of the coordinates of its endpoint. You can do this a couple different ways. You can, kind of go bounce, but we need to go from kind of go towards each other. But what we want to do is we want to practice that average. So here, your midpoint, we're going to take the coordinates 8 plus 40, 8 for P, 40 for Q. And we're going to divide by 2. We end up with 48 divided by 2 gives us 24. And again, if you want, if we have the number line, you can go, okay, we'll keep bouncing. There's 2, 3, 4, and figure out what they meet, but it doesn't always work that nicely. All right, so to find the midpoint of a segment on a coordinate plane, so now we're going to have our X and Y coordinates come back. We are going to find the mean or the average of both the X and Y coordinates separately. Okay, separately. We're going to do it all set up in one function as this with our formula, and on your formula chart that we provide you, it shows you in the last one under coordinate geometry, under distance formula, this is what we used in the previous problem. Now under the same thing, we have midpoint. You'll always have this formula provided for you. So just as if we got our x1, y1, x2, y2, and I showed with the distance formula, and highly suggest everybody do label your x1, y1, x2, y2, please. Okay? Now, we need to, just like with the warm-up, I had you guys highlight between. Here we need to make sure that we are highlighting the word midpoint. Okay, so we know we're looking halfway. We're going to find the midpoint of segment AB if these are our 2 points. Okay, so here let's look at our, plug it into our formula. Label our x1, y1, x2, y2. It's less likely to make a mistake putting into this formula. Here we're going to open up parentheses, and let's go ahead and fill in our x coordinate. x1 plus x2 over 2. We're finding the average of them. x1, 5, plus x2, negative 4. Make sure you have that negative 4. It's not, you're not putting 5 plus 4. It is a negative 4, all over 2. Then we have that comma in our formula. Now we're going to do the same thing with our y's. Here's our fraction bar. We have y1, 12, plus y2, 8, all over 2. If you want to take it one step at a time, you can. Here we have 5 plus negative 4 gives you 1 divided by 2. The other one, we've got 12 plus 8 is going to give you 20 divided by 2. We also do have the fraction function in the calculator where you can type 5 plus negative 4 in the numerator, 2 in the denominator, press enter. If we do that, we're going to find out that the x coordinate will be half, or 0.5. Your y coordinate will end up being 10. This will be your final answer. Okay. The big thing is making sure you're plugging the numbers in correctly and making sure your x, your 1s and your 2s are in the correct spot. Okay, so here we go. We're going to do it again. Find the midpoint. I'm going to go a little faster. I encourage you guys, this is pretty simple. Just plug in and, you know, let the calculator do the math. Work in your head too, but use the calculator to double check. So I encourage you to use number 2 as a basis to do number 3 on your own. So if you'd like to, pause it, try it on your own. Here, following our formula, P, we have x1, y1. Q, we have x2, y2. We'll plug in x1, negative 8, plus x2, 5 over 2. Now for our y's, y1, negative 2, plus y2, 1 over 2. If we take this one step at a time, the negative 8 plus 5 will end up being a negative 3 over 2, comma, negative 1 plus 1 is going to give us a negative 1 over 2. If we just did it all in one step, our final answer should come out to negative 1.5, comma, negative 0.5. I know some teachers are okay with you leaving it as a fraction. I prefer you guys doing it as a decimal, so if you have to graph it, you can find it easier. All right, let's take a look at the next page. Let's look what happens if I give you an endpoint and the midpoint. You have to find the other endpoint. We can do a working backwards using the formula, or the easiest thing is get some graph paper like this. Find the coordinates of J if K is at negative 1, positive 2. The midpoint of JL, that means J and, K is the midpoint. It's going to be between J and L halfway. So here's the midpoint K. L has the coordinates of positive 3, negative 5. So let's go down to positive 3, negative 5. Here is L. What we're going to do is K is the midpoint halfway. So going from L, the endpoint, to the midpoint, let's count the rise and run. How many spots do we go up and how many spots do we go over? Rising, we go 1, 2, 3, 4, 5, 6, 7. Running, we go 1, 2, 3, 4. To get to the other endpoint, it's going to be the exact same. So we're going to go up 7, 1, 2, 3, 4, 5, 6, 7, and we're going to run 4. 1, 2, 3, 4. I know we're kind of going opposite of what we normally do with slope, but this is where we can find it, and this will be J. Then we just read the coordinates out. J is going to end up at negative 5, positive 9. And this is how you show your work. Okay, we'll give you a graph so you can graph it out. Okay. Now we're going to take a look at what happens if we don't have a number line. We're going back to, we're going to be kind of looking at the segment addition, but now we're going to be looking at midpoint, halfway. So find the value of x if C is the midpoint. There it is. First problem, We saw between. You're going to have mixed problems. You have to know when is it halfway, when is it not. Midpoint tells you you have congruent parts on both sides of that midpoint. So we're going to, if C is the midpoint of segment AB, so here we're going to go ahead and draw out segment AB. C is the midpoint. We just eyeball it, but to let everybody know, hey, this is in the middle, put your congruent markings. AC right here is going to end up being 4x plus 5. And then it tells us AB, the entire thing, is 78. We're going to use segment addition postulate. Our part plus part equals whole. Problem is they didn't give us the other part. Guys, it's the exact same as AC. Okay, AC and CB are the exact same, so this is a 4x plus 5. So now if we do our part plus part equals whole, you can do it a distribution-wise, or you can write it all out, 4x plus 5 plus 4x plus 5. Here, let's go ahead and let's just write, I'm going to write this one out. That's what I did on my answer key to begin with. We have 4x plus 5 plus the other part, another 4x plus 5, all equal to the total whole of 78. So going through and making sure we are reviewing our solving for x here, we're going to combine our like terms. A positive 4x and a positive 4x will give us an 8x. We're going to have a positive 5 and positive 5, giving us plus 10, all equal to 78. Pause the video and finish solving this on your own. It's a two-step algebra problem. Finish it on your own, please. Decimal? Might be okay. We do wind up with 8.5. So let's take a look at another one here. We're going to have, this is a very, very common one. We're going to have our M is the midpoint of segment LN. So let's draw that out. You always want to make sure you draw this out. Segment LN. M is that midpoint. Ooh, I almost forgot to grab my highlighter. Make sure you highlight it so we see midpoint. It's not always the letter M for midpoint. That way we know to put our congruent segment markings here. LM, here to here, is going to be 3 parentheses x minus 7. MN, the other half, yes, I'm saying half because they're halves equal, is going to be x plus 13. Because of these congruent marks, if two segments are congruent, their measurements are equal. Okay, so we're writing here LM, segment LM is congruent to segment MN. Therefore, so these three dots mean the length of LM is equal to the length of MN. So we're going to take LM, 3 parentheses x minus 7. We're going to set it equal to MN x plus 13. Because we do have the distribution, I will go ahead and walk through this first part. We need to make sure with distribution, let's take care of that first. 3 times x will give me 3x. 3 times negative 7 gives me negative 21, then turn to a minus 21. And then we just bring down the x plus 13. Solving, we need our variables on both sides. Move the variable to the smaller coefficient. So let's get rid of that x, move it over. We're going to have 2x minus 21 equals 13. You have 2 steps left. Pause the video and do it on your own. It did ask us to find the length of LN, so we need to go back and figure out what this is. Okay, so what we need to do is we can just plug it into one of these. They want the entire length of the whole segment LN. So whenever we plug it into one of these, all we have to do is double it. We don't have to plug it into each one separately because they are the same thing. So here, if I think it's easier to substitute in for MN, the x plus 13, okay? So MN, we have as x plus 13. We're going to remove x, and we're going to substitute in what x is, giving us MN is going to be equal to 30. So now, LN, the entire length, all we have to do now is take 2 times MN. Just double what we have here, guys. So we take 2 times that 30, ln will equal 60. So there are different ways that you'll see this, okay? Now, when we take a look at this last thing, any line, segment, or plane that intersects a segment, okay, so here we've got our segment PQ. It's being intersected by plane A. We also see it being intersected by line KM. We've got another little segment right here. Anytime that it hits this segment PQ at the midpoint, we call it a segment bisector. The word bisector is important. We need to understand this means cuts in half. We're going to cut the segment in half. Okay? So when we take a look, in the left side figure right here, M is the midpoint of segment PQ. So like I just said, all three, the plane, the line, and this other segment all meet at that midpoint. So all of them are considered a segment bisector. Over here, we've got just line L cutting through at point N, making that line L, is a segment bisector. All right, we need to talk about fractional distance. About segment bisector, always know that's at midpoint, so you'll still use that, the two different segments being congruent right here, AN and NB. Fractional distance. A midpoint is 1/2 the distance from one endpoint to the other. Okay, half, there's that distance. You can also find points that are other fractional distances from the endpoint. 3 easy steps. 1, find the distance between those 2 points. Find the whole distance. Then multiply that distance by whatever fraction they're asking you. Here it'd be like if we find the distance between the 2 endpoints, multiply it by 1/2, we will find the halfway point, that midpoint, the distance of halfway. So here we're going to use the number line to find the point on segment CE that is 1/3 the distance from C to E. So step 1, let's find the distance, the entire distance from C to E. So we go over here, C to E, looking at C to E right here, and we can count it, okay, if we want to. We can find the difference between the 2 coordinates. If we want to count it, we're going to find that it's 6, or if we find the difference, the distance, we just take the difference between the 2 coordinates. So we can take, it's going to be the absolute value of the distance because it always has to be positive. If we take -4, we subtract the 2. These bars mean absolute value. In other words, just make it positive. It's the distance from 0, but make it positive. This ends up being 6. Step 2 is we take that distance, 6, and we multiply it by the fraction they want us to. They want us to go. So here we're going 1/3 of the way. And this equals 2. So to find the fractional distance from C, so this is our starting point, to E, put in here, move 2 spots closer to E. So we start at C, and we go, okay, I need to move 2 spots from C to E. We're going to go 1, 2, we find ourselves at point D. On this next one, this last problem dealing with this segment JK on the coordinate plane, we're going to find F on segment JK that is 1/5 the distance from J to K. So we're looking for 1/5 starting at J. We want to go 1/5 the way to get to K. So first let's look at how far are the X and Y coordinates from J to the X and Y coordinates to K. Let's look at the distance X, okay? Distance of our X coordinate, left and right. We're going to find ourselves to get there, 1, 2, 3, 4, 5 will land us in line. So we have our distance, our X distance is 5 because we went 5 units right. Distance for our Y coordinates up and down, 1, 2, 3, 4, 5 also. because we went 5 units down. We're just counting the units. Now we're going to find the fraction of both of those distances. Okay, so the other one's on a single number line. Now we're going two-dimensional x and y. So we have to kind of complete this for the x's and the y coordinates separately. So if you're x, the distance for x was 5. So we're going to multiply it by the fraction that they wanted us to do, 1/5. And well, 1/5 of 5 is 1. Now for our y coordinates, kind of an easy one here. We also went 5. So we multiply that by the 1/5, and we end up at 1 also. Now the last thing we need to figure out, where is this going to go on the graph? See if I can get both of these on here. We're going to increase the x and y coordinates of j, so we're going to take our j's coordinates, -2, 4. We need to increase these coordinates by what we found in this previous step, in step B. Okay, so we can figure out where are we going to be. Yes, you can move it on the coordinate plane as well, but here let's go ahead and see what happens if we don't have the actual graph. For x, we're going to take the x coordinate, -2. We're going to, well, B told us 1, so we're going to add 1. And we're going to end up at -1 for the x coordinate. Y, we have 4. Now, watch this. By increasing 1, we actually need to subtract 1. The reason why, okay, we're doing -1 on y because of the negative slope. The slope is actually a fall in run. So we need to decrease. The downward tells us decrease, subtract, go towards the negatives. Okay, so that is why we're subtracting this. And then we find out when we take 4 minus 1, we wind up at +3. So this is where you're going to find your 1/5 the distance. So here we go to -1, +3, and look at that right there. Please rewatch anything that you need to. Ask your teacher if you have any further questions, and make sure you're labeling those X1, Y1s, X2, Y2s.